Hello everyone. In this lecture, we will look at the definition of binary search tree and how do they work in data structures. During this lecture, we will look at the definition of binary search tree, illustration of binary search tree, properties of binary search tree, and operations of binary search tree. Binary search tree is a data structure that stores data elements in an organized way. Binary search tree is constructed by using nodes, and the structure of tree is formed with an extracted key value. The key value can be initialized manually or with a desired function of any that does fit the methodology of binary search tree. In this lecture, I will not be showing you how we will extract a key value from a given type of data, since it depends on the task and data that we have. But instead, I will be taking our data as integer and using same data as our key value to form our binary search tree. You will see in the next slide how nodes and key values are used to form binary search tree. The first node that is inserted in binary search tree is called as root node. A binary search tree should always start with a root node and have left and right subtrees after next insertions. So let's assume that we have data element of 10, and which is also will be our key value. The bigger from the left subtree of a node should always contain only nodes with keys lesser than the node's key. And the right subtree of a node contains only nodes with keys that are greater. So let's see it in an example. So let's assume we are inserting 7. So since 7 is smaller than 10, it would go to left subtree. And next, let's insert 13 as data element. As it is bigger than 10, it would go to the right subtree. Next, 8, smaller than 10, it would go left, and right since it's bigger than 7. The data element of 3, smaller than 10, it would go to the left subtree, and left of 7 as it is smaller than 7. 11, bigger than 10, it would go to the right subtree, and left of 13 as it is smaller than 13. And we would have such a structure after inserting more elements into our binary search tree. In basis, binary search tree has 3 main properties. The left subtree of a node contains only nodes with keys lesser than the node's key. The right subtree of a node contains only nodes with the greater keys. And there must be no duplicate nodes. But however, there's an exception. In future or at some point, you might see a binary search tree that supports duplicates. Binary search trees that support duplication should have a good way to manage duplicates without distracting the structure of binary search tree, which would be a common case if didn't manage properly. Eventually, we should try to avoid creation of duplicate keys, but instead try to have good functions that generate unique key for a dataset which will be stored within the binary search tree. Having a binary search tree with properly managed duplicates would increase time complexity of the binary search tree, since we needed additional operations to check if any duplicate exists in binary search tree. Duplicates supporting binary search tree could also worsen the space complexity. So this said, without further ado, let's have a look at the properties of binary search tree. Binary search tree has 4 common operations: insert with data element, search the data element, and deleting a data element in the binary search tree. Also, there are traversals that we can traverse through the binary search tree as in order, pre-order, and post-order. Thank you for your attention. In the next lecture, we will look at insertion and search operations in binary search trees. So, see you in the next lecture.